Bismillahirrahmanirrahim. How are you, dear student? Hope you are fine, good, and doing great. Your physics teacher Ziaul Haq. This is the Newton law of motion example solution. We will find also in this part some more example about the which we will use the Newton law, especially the Newton second law and tangent forces, etc. So let's see how many questions are in the second part. We will solve one by one. So let's see here, the system is given like we have now three masses in the system, m1 plus m2 plus m3. On the whole system there are 21 newton force is applied, which is equal to 21 newton. So this asks the tangent force here is unknown, find it. In the tangent force here is unknown, find it. So if we find the tangent force on one side, let's suppose this one, this will be equal to this tangent force, and if we find the tangent force this side, so this will be equal to this side. So let's see what they want in the question. Find acceleration. Acceleration is unknown, find the t1 and t2 and find the ratio of t1 over t2. So I wrote the value here, like if the force, external force is equal to 21 newton, m1 is 2 kilogram, m2 is 4 kilogram, m3 is 1 kilogram. Acceleration on the whole system, like if they are moved, so the acceleration is unknown, t1 is unknown, t2 is also unknown, and t1 by t2 is also unknown. Let's see, first we find the acceleration. To find the acceleration, we will use the Newton's second law, which is equal to ma. So in this system we have three masses. So let's see here, I will write like m1 plus m2 plus m3, because in the system we have three mass and acceleration is unknown and force is given, which is equal to 20 newton. Okay, now putting the value here, 21 newton is equal to m1 2 plus 2 kilogram plus 4 kilogram plus 1 kilogram, and a acceleration. So this is equal to 7 kg and the force is 21 newton time a. So a will be equal to 21 newton divided by 7 kg. This is equal to 21 divided by 7, 3 meter per second square. So this is the acceleration. One thing remember, if we find the acceleration, so acceleration is same for the each block here. So now if the second part, the first part is we find the first part. Now let's see the second part. We will find the t1. So I want to find the t1 here, so the t1 is also be same here. Only I want to find the tangent force on m1 block. So let's see, t1 is equal to m1 time acceleration. So the mass is given and acceleration already we find. So the mass of m1 block is 2 kilogram and time acceleration is 3 meter per second square. So 2 multiplied by 3 is equal to 6 newton. So this is t1 tangent 1, mean this one. So this must be same with this part on m2. So let's see here, one thing is, remember this tangent force will be different from this side force. Mean m1 and m2 tangent force must be different from m3 and m2 and m3 block tangent force. So okay, if I want to find the t2, so this side the external force applied on the m3, so this is toward the positive side and the t2 is toward the negative side. So I can write F minus t2 is equal to, in the mass block of mass is here m3 time a. So let put the values. So this is equal to 21 newton minus t2 is equal to m3 is 1 kilogram, and acceleration already we found here, which is equal to 3 meter per second square. So this is equal to 3 meter per second square, and this is 21 Newton minus T. If we turn this value or shift this value to this side, right side, so here the remaining part is minus T, 3 meter uh, per second square, kilogram meter per second square. There the 21 will be uh, plus T. So the value will remain is equal to, so no, here is plus, so here will be minus 21. So plus 3 minus 21 is equal to minus 18. So here is minus T, so minus will cancel with minus, so T2 will be equal to 18 Newton. So if you want to find the T1 over T2, so this will be equal to T1 is how much? 6 Newton, and T2 is 18 Newton, which is equal to 1 over 3. So this is the ratio of T1 over T2. So this is the first example of the second part. Let's see the another example. Now before all the question is on the horizontal surface. Now it is on the vertical side. The force is applied on the vertical side. So let's see, in this question only the force is given, and the mass of this block is given. They said that find the acceleration in this block. If we see this diagram, so there is another force is also create on the block, which is weight, and weight is already always downward toward the center of the earth. So let's suppose this is weight, so we must, this is goes toward upward, so the force will be positive, and this weight will be downward, so this we will put the value of this one is negative. So they only in this question they want to find the acceleration. So let's see how can we find the acceleration. So the two forces given, F minus W we will put in here. How many mass we have? One mass, m1. We want to find the acceleration. So let's see here, F is W, sorry, so W is equal to m1 times G, and this is m1a. If we put the value here, m1 is how much? 6, and G is how much? 10. m1 times a, so let's put the value 90 Newton minus this is equal to 60 Newton, which is equal to m1 is 6 kilogram time acceleration. So 90 minus 60 is equal to 30 Newton, which is equal to 6 kilogram time acceleration, and A will be equal to 30 divided by 6. So acceleration is equal to 5 meter per second square. So this is the remaining answer. Okay, let's see the another example. This is, here is a two block, and also they want to find the tangent here. This force is a little bit tricky than the previous one. So let's see, again they want to want the acceleration and also want the tangent force between these two blocks. Okay, first we will find the acceleration. So the force, external force is given on the system. This is the external force in 2 mass. Now I will write m1 plus m2 here, and G. Like this is the mass of 1 and mass of 2, both are downward, like the weight is downward of these two mass. So we must multiply it with what? G, mean the gravity value, force of gravity value, and also we put the m1 plus m2 time acceleration. So the force here is 18 Newton minus m1 is 3 kilogram plus 2 kilogram time G value mean 10, and also 3 kilogram plus 2 kilogram is equal to time acceleration. So 80 Newton minus 2 plus 3 is 5 multiplied by 10 is equal to 5a. So this is equal to 18 Newton minus 15 Newton, which is equal to 5 time acceleration. So the remaining value here is 30 Newton is equal to 5 time a. So acceleration will be equal to 30 Newton divided by 5, which is equal to 6 meter per second square. So this is the acceleration. Now if we want to find the tangent force here on the mass on mass m2 on the block of m2, so the tangent force, look at here, is upward but the weight is downward. So tangent force is toward the positive side and the weight is toward the negative side. So we can write like this: T minus W, which mass? We will put the weight we will use the W2 for the mass M2, and only we use the single mass of block, which is equal to M2 time acceleration. So now putting the value T minus W is equal to M2 time G is equal to M2A. Now putting the value here, T minus the value of this is equal to 2 multiplied by 10 is equal to m2 is equal to 2, acceleration is equal to 6. Now here this is equal to 2 multiplied by 10 is 20 is equal to 12. Shift the value here, so this is equal to 12 plus 20, so the tangent force will be equal to 32 Newton. Now if you find the want to find the tangent force here on the mass 1 block, so here the tangent force is also downward and the weight is also downward. So I will just give you the hints so you can solve this question, like how this tangent and this tangent is same on mean of M2 block and M1 block, the tangent force is same. Just I write the formula here, then you can find. Let's see here, F minus T plus W 1, we will put only the weight of mass 1, which is equal to m1 time a. Now you will put the value in this equation, so you can find the tangent. If you find the tangent from the mean this tangent, so this is also equal to 32 Newton. So use this formula and try to find the tangent. Okay, thank you so much for this example, and be stay with us in the next part. Inshallah, we are trying to solve some more question in the part 3. Thank you so much.